Okay, we're still in 2.4, polynomial and rational functions, and we'll now take a look at an application of rational functions. That will be the last example in this section. We looked at bounded already, so here's an application, here's an example. A company that manufactures computers has established that on the average, a new employee can assemble NFT components per day after T days of on-the-job training. And it's given by this function. NFT is 50t over t plus 4, where t obviously has to be bigger than or equal to 0. They want us to sketch a graph of n on the domain between 0 and 100 for t, including any vertical or horizontal asymptotes. What does NFT approach as t increases without bounds? That's the question. What does NFT approach as t increases without bounds? So before we do anything, why don't we first make sure we understand what's happening here. So this company manufactures computers, and they've established that on the average, when they hire someone new, that new person can assemble NFT components per day. Okay, so the units of time are day here. After T days of on-the-job training. So you hire someone new, you give them T days of on-the-job training, where T is between 0 and 100, and based on that, this is the number of components they can assemble after day T. Okay, that's when they had the on-the-job training. So why don't we go ahead and do this problem next. Notice that since n of t is 50t over t plus 4, you can have a vertical asymptote only where this function is undefined, and that's t equals negative 4. However, our domain is all the t's bigger than or equal to 0 and less than 100, so t equals negative 4 is not a part of the domain. Thus, there are no vertical asymptotes for t bigger than or equal to 0. Okay? As far as the horizontal asymptote goes, remember, we're interested in seeing what's happening in the long run as t goes towards positive infinity or negative infinity. Okay? And to see that, notice once again that in this situation we have same degree, 1, for both top and bottom. And from our cases that we looked at earlier, when the degree is the same, we look at the leading coefficients of the top and the leading coefficient of the bottom. We look at that ratio to determine the horizontal asymptote. So the horizontal asymptote here is going to be 50, the leading coefficient of the top, over 1, the leading coefficient of the bottom. That gives you 50. So the horizontal asymptote here is really y equals to 50. Okay, so n of t approaches 50 as t increases without bound. So y equals to 50 is a horizontal asymptote. Putting it all together, here's what the graph looks like. You could graph this with a graphing calculator as well to verify. Use the window between 0 and 100 and 0 to 75. That's a good window to see it. And you will notice that as n of t approaches 50, as t increases without bound. So it appears that 50 components per day would be the upper limit that an employee would be expected to assemble. He just wouldn't be able to get above 50. That's the top, the most that the employee could do.